Hi everyone. So in this video, I'm going to discuss the topic of contact force. Okay. Now, as the name suggests, contact force means it arises when one body is in physical contact with another body. Okay. So suppose this is one body and this is the horizontal surface. So this body is in contact with the horizontal surface. So here we will have a contact force. If the body moves in the forward direction, there will be friction force acting in the backward direction. Okay. Now similarly, suppose you have one block and there is another block, both are in contact. Okay. Now if you apply a force on the bigger block, there will be an interactive force between the bigger block and the smaller block. Okay. So again here the two blocks are in contact, so that force that arises here at the point of contact, that is contact force. Okay. So examples of contact force are ropes or strings, force exerted by ropes or strings. So we will discuss these cases also. So that those forces which arises in ropes or strings, it is called tension. Okay, we will discuss this also. The force involved in collisions, the force of friction between two surfaces, and the force exerted by fluid on its container. Okay, so that is the upthrust. Okay, that you have learned in the chapter mechanical properties of fluids. So these are the various examples of contact forces. Okay, so now these are few examples of contact forces. Okay, now let us take one example. Like suppose you have a horizontal surface. Okay, now on this horizontal surface you have a block of mass capital M and you have another block, okay, of mass small m. Now they are in contact. Okay, they are in contact. Now suppose the bigger block is acted upon by an external force F. Okay, so this is the force acting on this mass block of mass capital M. Okay, acha. Now since the two blocks are in contact, now this block of mass capital M, it will exert a force on the block of mass small m. Okay, now suppose that force is small f. Okay, now this force is the contact force. Okay, contact force, we are representing contact force by the symbol small f. Okay, now this is the force exerted on small m by capital M. Okay, now because of this contact force, this block of mass small m will also exert a force on mass capital M. Okay, so that will be how much? That will be same force but in the opposite direction. So this is F. Okay, so always do remember that this contact force, whenever it arises, it occurs in pairs. Okay, so here, so this force is like an action and this is like reaction. Okay, action and reaction are equal in magnitude and opposite in direction. That is Newton's third law of motion. Okay, now suppose both the blocks are moving with same acceleration. Okay, now for this smaller block, I can redraw this as, suppose this is mass m. Okay, and it is placed on a horizontal surface. Now it is acted upon by a force F, small f, this force. Okay, and it is moving with acceleration a. So this force is causing acceleration a on mass small m. So from Newton's second law, I can write F is equal to m times a. Okay, now what about the bigger block? Now for bigger block of mass capital M, okay, now it is acted upon by two forces. Okay, Okay, one force is now it is acted upon by two forces. One is capital F. Okay, this is acting towards right. Okay, so let me mark it. So this is capital F acting towards right, and this contact force small f, it is acting in the opposite direction. Okay, but this mass is moving in the forward direction with the acceleration a. It is acted upon by two forces, capital F, okay, and small f in opposite direction. But it is moving in the forward direction. That means this force is of greater magnitude. Okay, so the net force will be F minus F is equal to net force equal to mass into acceleration. So mass capital M into acceleration. Okay. Now what about this force? This force is F equal to ma. So if we substitute this value over here, what do we get? F minus ma, it is equal to ma. So if we take this to the other side, it becomes F is equal to m plus m into a. So that gives a is equal to F divided by m plus m. So this is the acceleration. Okay. So now we have the expression for acceleration. So now if you substitute this value over here in this equation, you will get the value of the contact force. So contact force, it will be equal to m times acceleration. So small m times capital F divided by m plus m. So this is how you can find the expression for the contact force. Okay. Now here, this is the contact force when the force capital F, external force, is acting on mass capital M. Okay. Now you may check this in your end, like if instead of the force, this force acting from the left hand side, what will happen if the force is acting on small m from the right hand side? Okay, then in that case, what will be the expression for the contact force? Okay, you please try this in your end. Okay, using the same concept. Okay, so this is how you can find the contact force arising between two masses in contact. Now let us learn another type of contact force, that is called tension. Okay, now this tension, it is the force exerted by string on connected bodies. What do you mean by connected bodies? Let's see one example. Now suppose we have a horizontal surface. Okay, and on this surface you have two blocks. Okay, now these two blocks are connected by a string. Okay, so this blue color represents a string. Okay, now this string has certain features, like it is massless, it is inextensible, okay, and it is tight, okay. So these are the three features of an ideal string. Okay. Acha, now suppose this is of mass small m, this block, and the other block is of mass capital M. Okay, now let's say this block of mass capital M, it is acted upon by horizontal force F. That means you are pulling this block of mass capital M with force capital F horizontally in the forward direction towards right. Okay. Now this block of mass capital M, it is connected with a string. So it is going to pull the string. This mass M will pull the string. That is action. So reaction will be the string will also pull the mass. That is, action and reaction are always equal in magnitude and opposite direction. So this force exerted by the string on the mass, that is called tension. Okay. So that means this tension, it is a type of reaction force. It is a type of reaction force. Okay. Acha. Now the same string is also connected to mass small m. So here the string is going to pull this mass in the forward direction with the same tension T. Okay, with the same tension T. Now see, if the string is massless, for this feature, tension at all points will be same. Tension same throughout the string. Throughout a string. Okay. So at all points on a string, same string, tension will be same for this condition, for massless string. If the string has mass, tension will be different. Okay, that is a different scenario. We will handle it later. But for the present scenario, massless string means tension same throughout the string. Okay, so that is why both locations I have marked same T. Okay, otherwise it will be T1 and T2. Okay, so this is the tension. Tension is the force exerted by string on, suppose on this mass, it is pulling this mass, string is pulling this mass small m with tension T. Similarly, for this mass capital M, this string is pulling this mass with tension T. Okay, so this is the term information about tension. Okay, now let us calculate how much is the tension. Okay, now if you see the block of mass small m, okay, now it is acted upon by force, this force. Okay, now assuming that both the blocks are moving with same acceleration a, so tension T is causing acceleration a on mass small m. So that means T, it is equal to small m into a. Okay. Now for the other block, this block of mass capital M, it is acted upon by force capital F in the forward direction, tension T in the backward direction, but the block is moving in the forward direction. So that means this force has greater magnitude. So the net force will be, net force on capital M, it will be F minus T, net force. That is difference of these two forces because the forces are acting in opposite direction. So F minus T is equal to mass times acceleration. So mass times acceleration. Both the blocks are moving with same acceleration. Okay. Acha. Now if you substitute this value of T over here, you get F minus small m into A is equal to capital M into A. Now if you take this to the other side, this becomes F is equal to M plus M into A. So that gives A is equal to F divided by M plus M, small m plus capital M. So this is the expression for the acceleration. Okay. Now if you substitute this value of acceleration in this equation, you will get the value of T. So this T becomes small m, this is small m, okay, small m times capital F divided by M plus M. Okay, now this expression looks identical or similar to the contact force that we have derived previously. Okay, so now here we get this expression for tension. Okay, so this is how you can calculate tension in string. This is one case. There will be other cases also, but here I am discussing a type of contact force. Tension is a contact force, and how to arrive at the value of the contact force. Okay.